This time, we'll move into the white box and work on the MoE for a subsystem step. First, we'll create the package for this step, and then we'll review the requirements again. For those requirements, we'll take non-functional items like total mass, sound level, and energy consumption, and turn them into measurable and numerical properties, meaning parameter value properties. In this step, we'll create a BDD, and for a diagram name, just remove the number. That's enough. Next, we'll find the MoE holder block we created in the black box stage and move into the new diagram since we are defining MoEs at the subsystem level. We'll start with the example subsystem, the cooling system. Then we'll connect the cooling system to the MoE holder using the generalization relationship. After that, we'll go to the cooling block properties, symbol properties. We'll change the view to the all, and in the search box, we'll type INH and set the show inherited to true. Once we do that, the inherited property will appear in the diagram. Now, we'll open cooling block property window, specification window. You'll see the inherited parameter value property have a small angle bracket style indicator. For each of those, we'll use redefine to convert it into the value property that belongs specially to the cooling block. After redefining, we'll rename each property so it fits to the cooling system context. The main benefit here is that through redefine, we can reuse the same unit system and types we already defined earlier, instead of rebuilding them from the scratch. At this point, we may want to shrink the cooling block width, but sometimes the text length looks fixed and one reduced. In this case, open the symbol property and set the shrinkable blah 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 to the true. Then block can be resized. So you can repeat the same workflow for the remaining 3 subsystems: heating, processing, HMI. So the advantage of this inheritance and redefine approach is that it let us reuse and redefine parameters based on single source. So things like value types and units stay consistent. The downside is that you still need to redefine each property one by one, which can be tedious. Also, after you set those symbol property like shrinkable, you can set them as a default so that newly created block inherit the same symbol property automatically. So from here, we'll switch to the fast forward section and move on. That completes the MoE for subsystem step. So we'll save the model and continue. Next, we will cover traceability to stakeholder needs, which is the final step of the problem domain. Under the problem domain package, we create a fourth package called traceability. Then We'll type RRM to create a refined requirement matrix, and we'll give it a name. In the matrix, there is a column. In the matrix, there is a criteria, and we need to configure it. First, we drag and drop stakeholder needs into column scope. Next, we'll define what goes into the role side. We'll select one call behavior action. For example, initialize cooling. And we'll drag and drop it into the role element type. Then we'll add part property as well. Here's a detail. When you drag and drop additional type, you must hold Control in the keyboard while dropping it. If you don't hold Control, the existing type gets replaced instead of being added. We'll also add value property type for role scope, and we'll include the entire white box package. We can also add type like a proxy port by clicking the type selection button in the property. The reason we configure the criteria this way is to ensure that starting from the black box requirements, we can bring all relevant white box model elements into the matrix raw. So we can map which model elements refine which requirements. To create relationship in the matrix, you can double-click the cell to create a refined relationship. Or you can select multiple cells using Control in the keyboard and right-click and click the refine relationship in batch. From there, we continue building relationship across the matrix. Just as MagicGrid BoK document. This part is repetitive, so we'll fast forward. In practice, many users find this uncomfortable because you have to create relationships manually one by one. For people who haven't done system engineering work before, it can feel unnatural, but if you want true data traceability, this is a necessary step, and it requires engineering judgment and review. Over time, this manual work can be improved by AI. For example, AI could propose draft relationship, and engineers could review and confirm them. Also, traceability is not something we expect to complete perfectly in one shot. Modeling is an engineering process, and it includes review cycles. So traceability relationship will be created and refined step by step through those reviews. In this kind of tutorials, it can feel like a burden, but in real engineering work, it can be handled more naturally as part of the workflow. After we finish creating the relationships, you may notice that the BoK document shows implied relationship as dashed lines, but they might not appear in our model metrics. To fix that, go to Criteria, and next to the dependency criteria, click the three-dot button. In the setting, we can configure how implied refined relationships are displayed. Go to Target. In the target corresponds to the white box, meaning the role side. Right now, the matrix only generates implied relationship based on relationship it recognizes like a generalization and part. That means only elements connected through generalization and part inside the white box can produce implied relationship, but real models are usually more complex. So we'll add more relationship types. Select body, choose on the element, set the direction to the target to source, then click OK and refresh the metrics. After that, the metrics should match the format shown in the BoK documentation.